is 6.2 orbits and Kepler's law. From the previous knowledge, we know that if you have a satellite or any object going around Earth, the velocity that the satellite is obtaining, it depends on the distance to the center of the Earth R and just the mass of the Earth. And that's the relationship. Is the square root of G constant, mass of the Earth divided by the R, the distance between the satellite and the center of the Earth. Here, determine the speed of the second and the third planet from the sun after it's for the required data. So we just know the mass of the planets, mass of the sun is 1.99 10 to the power 30. We know that the RVs, the distance between the planet and the sun is 1.08 10 to the power 11. You just want to find the v velocity of that. Here, we know the equation. We just put the numbers. We got the velocity. We do it for another planet, and we can find the different velocities. So you can try number 3 and 4. Now, Kepler law of the planetary motion. So the first law saying that the Earth's planet move around the sun in an orbit that is an ellipse, with the sun at one of the focus. So it sees this is an ellipse, and any ellipse had 2 foci. We call it F1 and F2, right? The sun is located as in one of these focals, and as you see, the planet is going around the sun in these elliptical shapes. So Kepler's second law of planetary motion say a straight line joining the planet and sun sweep out equal areas spaced in equal interval of time. Look at the state. Let's say the planet is here, and after the time delta t it is there, right? If this area and the area here is here and is sweeping that in amount of the delta t. If this delta t and this delta t are the same, so it means the area 1 and area 2 is the same, or reverse. When the area 2 and area 1 is the same, means the time it takes come from here to here is the same as here. Means at this point it is moving much more slower than this part, right? It's more faster. But the distance here is much more bigger than the distance that is going here. Okay, third law. The third law says the cube of average radius r of the planet orbit is directly proportional to the square of period t of the planet orbit. So just think that r power 3, which is average radius of the planet, divided by period power 2 is a constant. So look at this question. An average radius of orbit of the Earth about the sun is given to you. The period is given. Determine the constants. Easy, just according to this equation, the r, that number power 2 divided by that number power 2. Here's power 3, here's power 2. You just calculate, just put in the equation and calculate that. An asteroid had a period of revolution that many seconds. What is the average radius? So make sure when you do the period, first period, you need to convert it to the second. Now, since if we have this constant, we use this constant because I know this equation, I know the constant. Now, in the part B, the t is given, and I'm looking for r. And just simply just rearrange for r, and you can find the average radius of that asteroid.